Hi guys, yesterday I have said about nested quantifiers. I will continue the session. Let's check on this. Here's an example. P of x comma y is equal to x plus y. This is a propositional function which has variables x and y. There are given options. It is a previous calculation. Y, P, there exists x, there exists y. C, for all x there exists y. D, there exists y for all x. Let's check this. First one. For all x, for all y, it should be true. It's scrap now. ये बकवास का statement. X plus y is equal to 10. When x has some integers. So okay, I have to say something. Domain is integers. Okay. I will say about domain. No, after 3 minutes. After saying this question, I will say about domain. Let's work. Domain means, for now you think that the values of x and y should be taken from this domain. We will say function now. F of x is equal to a. X is domain, a is range. Means not a is range and x is domain. The values we put in x is domain. It is the subset from which we take the values to x. It's the set of a to which we mapped with the function. It's the range. Like that. Don't think about range here. There is no range. There is only domain. I will increase the speed. Okay, no problem. For all x, there exists for all y's. Means let us consider 1 and 1. Is 1 and 1 is 10? No. For every x and for every y, if we take a mapping, it should satisfy this. You see, it is Bakwas statement. So it's wrong. A is wrong. For B, there exists x such that there exists y. In this x set, there exists at least one y corresponding to any x. We can take 5 and 5, 5 plus 5, 10, 7 and 3, 7 plus 3, 10, 8, 2, 8 plus 2. There exists at least one mapping. So this is right. For all x, there exists y. Yes, see, for all x, there exists some y. Means for all integers, there exists some y. Means for everything, we have to map any at least one. Okay. If we take 1, we have 9. If we take minus 1, we have 11. If we take minus 10,000, 10,010. Okay. So this is the resistance for all y. Means there exists a y for all x. For all x, there exists a y. Means C. Yes. Y is constant. Okay. Y is constant for all x. That's only the meaning. There exists a y. There is one y for every x. Okay. I will say a trick now. Listen this carefully. If there exists in this equation, there exists y for all x. Y is equal to 10 minus x. Keep it like this. Take the there exists terms this side and left hand side, and remaining are RHS side. Now, if there exists is outside, check there exists is outside. Check constant or not. If it is inside, check it is in domain. Find a contradiction. I'll say what I mean. See, there exists y for all x. There exists is outside, means it is the outside of for all x. Then every time we should, if we find that there exists y, so we will write the function in terms of y. Y is equal to like that for f of x. F of x is 10 minus x. If outside, we will check y is constant or not. Y is equal to 10 minus x. Is y is constant? It is depending on x, no? If x is equal to 2, y is 8. If x is equal to 3, y is 7. Y is not constant. So this is false. Now we say for all x there exists y. There exists is for y, so y is equal to 10 minus x. It is f of x. But it is inside, so we should check whether it is in domain by keeping values. Finding contradiction means, is there any contradiction for this one such that y is not in domain? No. 10 minus x is an integer. For every integer, 10 minus integer is integer. Y is integer. If you say any x for that x, we are getting y as irrational. You can say it is false, but we got it as integer, so it is true. So is a trick. Let us apply another question. X plus y square is equal to 10. For all x, for all y, is it equal to 10? No. There exists x, there exists y, such that it is true. Yeah, there may be any one. 1 plus 3 square is 10. 2. There exists for all x, there exists y. There exists y. So y square is equal to 10 minus x. Y is equal to root of 10 minus x. Y is inside, so we use this formula, this method. Put x. X domain is integer. Sorry, domain is integer. Root over 10 minus I. Root of integer y. Y will get root of integer is irrational, no? It is not a integer, so it's wrong, false. Okay. Next, there exists y for all x. These two are not same, okay? Don't confuse. Y is equal to put out and x. Y is outside. Is y is constant? No, it is depending on x1. If x is equal to 2, y is equal to root 8. It will change, it is not constant. False. Next. For all y there exists x is equal to 10 minus y square. X is inside. Check the domain, 10 minus I square. X is equal to I square will be I, no? I. Okay. Definitely it will be true. For all x. Sorry, there exists x for all y. X is equal to 10 minus y square. X is outside, so we'll check it as a constant or not. No, it is depending on y, so it is false. We have to this one is true, this one is true. That's it. Yeah, it's the right answer. If you write any KTX or cat, there will be questions like nested quantifiers, which are in 3 variables also they may be asked the question. It tells y is independent on x. So sir, this z. Y is independent on z because y is outside the z. It's constant for z. Z and may or may not be dependent on x. This is the point you have to remember. If y is like that, you should break the function in terms of y is equal to something. You should check whether y is constant for z or is depending on. That's it. Let's solve the question. P of x comma y comma z. X plus y plus z is equal to 10. First one, for all x, for all y, for all z. For all x, for all y, for all z, is 10? 1 plus 2 plus 3 is it 10? No, false. There exists y, there exists z. Yeah, it's true. 9 plus 1 plus 0. It's true. Okay. For all x, for all y, there exists z. Z is equal to 10 minus y minus x. Z is inside, so keep 10 minus I minus I. 10 minus I. So Z is in the domain. Z is true. Third one is also true. This one. For all x, there exists Z. For all y. Z is equal to 10 minus 5 minus x. Z is outside the y, so it should not be depending on y, but it is depending here. It is depending on y now. So, false. There exists Z for all y. Okay. Here Z is equal to z should not be depending on x and y, but here it is depending, so it is false. Here x plus y is equal to tan minus z. There is outside, ये बाहर है, x plus y is it depending on z? Yes, false. Take this one. X plus y is equal to 10 minus 1. They are inside. X plus y is equal to 10 minus I. It is I. X plus y is also integer. So, okay. By practice, it will become easy.